Okay, let's take a look at our last problem for this unit. All right, these are percent yield problems, which is kind of the end all be all in the reason why and how chemistry works in industry. And it's not really just industry, it's really everything. But it's how much we can get out of the stuff we start with. And the goal is obviously whatever we put in, we want to get 100% of that out. That's not realistic. But the closer we get to that, the more money as a company we can make. And a lot of times it doesn't have to be chemistry, but that same idea, no matter what your future might hold, potentially has that same idea. So let's look at this concept and see what we got. So percent yield. We start with an experiment with a 19.5 gram sample of sodium sulfate. We end up producing 13.6 grams of sodium phosphate. What is our percent yield? All right, so a couple of things. We have two numbers. This is the first time we've ever seen two numbers. We're not going to use two numbers. What we need to realize is this is what we start with, and this is what we produced. Only one of those is going to go into our chemistry. And the one that goes into our chemistry is going to be this guy. All right? Because what we're going to try to find is we're going to try to find something called the theoretical, right? The theoretical yield. The theoretical yield is the best. That's 100%. And then we're going to use that number and we're going to compare it to what we produced, which is called the actual. Okay, and I'll write this all down in a second, but we're going to go through our same steps, and I'll go through that whole drawing it out right now, just so you get it again. So write down what we know. All right, so we have 19.5 grams of sodium sulfate. So we look on here, sodium sulfate's right there. And so I'm just going to write down my 19.5 grams, right? And then I'm going to draw my arrows. I need to go down because I need to be to the mole level. Okay. And then where am I going to end up? Well, I need to figure out how much sodium phosphate I could have made, right? How much should I have made? If I did this 100% perfectly, what should I have made? So sodium phosphate is way over here. So we're going to go backtrack, and then we'll finish with blue again. All right. So knowing, and what we're going to find out here is we're going to find an unknown mass, right? An unknown grams of that guy. And so this guy's going to be a three-step process. And this is going to get us our, how do we spell that wrong? All right, yield. That's what we want, because then we're going to go back and we're going to use our equation, which I'll show you in a second. So keeping the colors kind of the same, I'm going to move this up a little bit. So I'm going to start with my 19.5 grams of my sodium sulfate. Okay, there we go. I'm going to go down. So again, I'm going to hit my mole level. So I'm going to get rid of grams. So I'm going to put grams of Na2SO4 right here. I'm going to put moles of Na2SO4 right there. If we have grams, we have to have moles on top, and it's got to be of the same compound. Really important that we understand that. All right. And so I have 1 mole. We calculate, we look at our periodic table, and we understand that we have 142.1 grams. Good. I'm here. That step is done. Let's go on to our next step. So I'm going to cross that out. I know I'm done with that. Just like dimensional analysis always shows us, I'm going to put moles of Na2SO4 on the bottom. Okay. What am I trying to get to? I'm going to go along my mole level, my mole to mole ratio. So my moles are going to go on top, and I'm going to go up to my sodium phosphate, or to my sodium phosphate. So I'm going to write Na3PO4 right there. Here, my mole to mole ratio is always my coefficients. So put the 2 on top, put the 3 on the bottom. Awesome. All right, so I'm going to cross out what I just got rid of. That step is done. So let's go to our third, and in this case, final step 4, my theoretical. So again, moles of Na3PO4 over grams of Na3PO4. Again, grams and moles, doesn't matter what's where. This is called our mole ratio, and so this again is a 1. It is not a 2. We're not bringing the 2 down there. Okay, This is for every 1 mole, how many grams? That's what the periodic table tells us. And if we look up this is 164.0. Moles of Na3PO4 are canceled, and we can do our math. So our theoretical yield comes out to be, just write it down, putting it in our calculator, so we have 19.5 divided by 142.1 times 2 divided by 3 times 164. That is not right. Let's try that again. 19.5 divided by 142.1 times 2 divided by 3 times 164. There we go. That looks a lot better. And again, that's where if you understand that showed me a negative 10 to the fourth exponent. I knew the number couldn't be that big. I'm not dealing with numbers that are that drastic. So I end up with 15.0035. So 15.0 is good enough. And this is grams of Na3PO4. All right, so we just found the perfect amount. Now what we got to use is the next step is actually pretty simple. We just got to remember to use this. To find percent yield, all right, so to find percent yield, it is the actual yield over the theoretical. Okay, and then it's times 100. So in this case, my theoretical is this guy. That's what the stoichiometry gives us. It gives us the perfect answer. So I'm going to write my 15.0 grams of Na3PO4 here. And what I'm going to put on top is what it said we produce. This is what we in a lab would have got. So I end up with 13.6 grams of Na3PO4. Notice these two things should be the same. We're getting a percent yield, we're getting a percent, and we're trying to distinguish how well did we do versus what we could have, should have, hopefully did do in times 100. So in the end, our percent yield is equal to simply 13.6 divided by 15.0 times 100 to get that percent. And we did 90.7%. Okay, so what this tells us, that number, is it's giving us an indication of kind of more like our losses. And it's saying like almost 10% of our reactants, or in this case, 10% of whatever we started with was lost, was not converted to our final project. So in a lab, that can be a lot of different things. You could think of it as being like, hey, I started with 10 pounds of hamburger. If I was trying to make, 10 1-pound hamburgers, maybe one of my hamburgers fell on the floor. And so that means my profit margin, because all of a sudden 10% of my stuff that goes in is gone, I'm going to lose a little bit on it. So the closer we can get this number to 100, the better job we've done. Right? So 90 is not too bad. Anything above 10%, like if we were actually doing labs in this class, is good. When you go to college, lots of times that gets closer to 95. You got to be within 95% or better of your percent yield in order for your professor to count that lab. All right, so there's a look. I'll be seeing you in a little while.